Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, my name is Jean-Marie. Today we have a physics as usual. And the physics that we have is for Unit 4. And this Unit 4, we are discussing on work, energy, and power. So, and into this unit, you know just the key components of this unit. By the end of this unit, I want you to be able to evaluate the relation between work, energy, and power, and the resulting phenomena. So, and I think that from the time that we have started this unit, you are able to just to give, so at least the relationship between this work, energy, and the power. But we are trying now to relate with the other phenomena, right? Good. So the lesson number 6 is where we are in, and the linear momentum. So you check this lesson on page 172, 175 from the book of Senior 4. And the objectives of this lesson, by the end of this lesson, I want you to be able to describe the linear momentum. That is 1. 2, to identify conservation of linear momentum. That is another point that I want you to be able to know, but after we explain this unit, okay? So we have lesson number 6, as I'm telling you. So now, students, I have a question here. What is momentum? It is your time now to recall, because this concept, you saw it into Senior 3. Do you remember that? Yes, that's good. Linear momentum, as you know, it is linear momentum is, of course, denoted as P, and then let's put the arrow here. So I will now tell you why. So it is denoted like this, and we define it. It is defined as the product, very simple, product of mass and velocity. So this is how we define that. So in very, very simple now, you can have this is equal to mass times v. That is the velocity that we are having here. So it means that here we have a velocity, and this is the mass. And here we have a linear, so simply we have a momentum. Okay, students. So after we have this definition, so of course it is what I'm telling you there. So then unit of that, so we may have now a unit. So the unit is kilogram meter per second. Why? Because as what you see, we have linear momentum equals to mv, and this here, it is expressed into kilogram, and the unit of that is meter per second, and then the unit of that one is going to be kilogram meter per second. This is what we have now. So, and because we are having this velocity, you remember that velocity is a vector quantity. Do you remember that? So from Senior 1, you have defined what is a vector quantity as a quantity that has both the direction and the magnitude, the size. That's good. So it means that it is a vector quantity, because it is expressed from the fact that it is expressed from the fact that velocity is a vector quantity. So now here we have, that's why what we have here. So we are saying velocity here, then because it is a product of mass, what is going out to be given out from here as a momentum is going also to be a vector quantity. Do you understand? It has both the direction and magnitude. So senior 4, I think that you are together with me, okay? So good. Now let's have, it is what I'm telling you there now. Let's have immediately the quick example, the activity. So calculate the momentum for the diagram below. Guess what the diagram that I'm going out for you. The very beautiful car. So we have the speed of this car is 16 meters per second, okay? So you have the mass is 2,000 kilogram. And the car, of course, is subjected to move, having this direction. It is now forward, okay? So students, I'm giving you now some few seconds because you saw this, and then you find the answer. Hurry up. Okay, so you have some seconds. 1, 2, 3, 4, 5. Now, I think you have obtained the answer. So what you have to do here, let's answer. To answer on this, I want you to just the given. You know, here we have the mass. The mass is 2,000 kilogram. And another thing that we have is the speed, the velocity. The velocity is, what we have there is 16 meters per second. And then students, what are we going now to do? We apply the formula. So because we were asked to find the linear momentum. What is this linear momentum? And we find this linear momentum equals to mv. Then we substitute. We find 2,000 kilogram times 16 meters per second, right? And what do we find? Very simple. You can multiply this by 16. And what do you find? You find that 2, and then you add on these 3 zeros, and then you find the kilogram meter per second. So I think that you have obtained the same answer as what as what we are obtaining here. That's nice. So the answer is what I have just provided just to you. I think now you can copy wherever you want, either here or there. They are the same. But now here it is very in short, and here it is a little bit in detail, because I try now to put here the data, and then I say what is being asked, and then you can now just get the answer there. You have finished it, I know. So then let's continue. I have the same cars, but this time I have one car. I named it A and B, the 2 cars. This is activity number 2. From the same given cars, the same given cars, the same means what? They are with the same mass. Good. Which one has more momentum if they are subjected to move at the same time from the same location? Can you give the answer? That's correct. The one that will have this more momentum is the one that might have the very high speed. Do you understand? There is a reason why. As what we saw into the formula, we saw that from the formula, from the expression here, expression of the momentum, okay? So, okay, the answer is that one, but we are going to explain, okay? So from the expression of the momentum, so we know momentum equals to mv, like this one. So if we try now to understand what we have here, so we find out that the momentum is going to depend on the mass of the object and the speed of that object, which means that if you have the two objects having the same mass, the one that has a high linear momentum is that one with the high speed. I have the object, the balls here, this one. They are the same mass, this. But if I'm going now to move, I'm going now to give the speed to these two balls at the same time, from the same point. So the one that will be with a high linear momentum is the one that I give a high speed, but the one with the low speed will not have this more momentum as what we have there into the cars. Do you understand? This is how you have now to answer on this question. In another word, if we have now specified that a car A has high speed and a car B has low speed, this time now you would have to answer saying that because this one has high speed, and then you would have now to say, okay, the car A is the one that has a more linear momentum. That's good. Now let's have the interpretation to these ones again. So it means that this means that the same cars, the same objects with different masses. So the one with more linear momentum is that of high speed. That is one. And if they have the different masses, the one with more linear momentum is that of more mass when they are moving at the same speed. So I'm trying now to give you this point so that you understand the description or how you can describe and define or explain the linear momentum. Okay, let's now move on to the next point, and this is the principle of conservation of momentum. Students, I have the device here. The device that we have is this one, okay? So this device is the one that we are saying in Newton's clado with a certain velocity before the collision. Then we must have one ball with the same velocity after the collision. The collision means the interaction, means the objects they are going to move, to meet. All the balls of the Newton's clado have the same mass. These are the balls that we have, and I want you to count how many we have. If we have the one ball of the Newton's clado with a certain velocity before the collision, then we must have one ball with the same velocity after the collision. We can do this to demonstrate that one. So I think that you have finished to count that we have 7 balls. right? They are all with the same mass. They are the same kind as the one that I have shown you. So this is the one ball. So when I release this ball, do you see that one, how it moves? I'm going now to repeat this again. So listen, we are saying if we have one ball of the Newton's cradle with a certain velocity, this is the velocity. The velocity, you see, I'm giving you this one, the velocity. So with a certain velocity before the collision, before it collides this one, then we must have one ball with the same velocity, one ball here. So this is one ball at this one, at this end. But guess what? If we have a two, and then we are given the speed, what do you think will happen? Remember, they all have the same mass, and then we are giving the velocity to these two balls. Good. The two masses will move with the same velocity as the one that was colliding with this one. Okay, let's now observe that. We have that. Do you see that? We have that. It is moving. But the way now you see this one, again, striking the two, and then we have this one also moving away. So if we have a three, of course, the three ones will move, as I think that you are observing that one. This is really very important now for us to observe what we call the linear momentum and then the conservation of linear momentum that you are going now to explain into this diagram. So we have the principle of conservation law of linear momentum or momentum state that in a system made out of objects that react, so that collide or explode, the total linear momentum, the total momentum is constant if no external force is acted upon the system. So we have the masses, the two masses. One is, here we have the conservation of linear, let's say we have this linear momentum, right? So there we have, before collision, and then you have after collision. Now, students, as what we are saying here, we have a mass of U, this is U1, and this is having a mass M1, and you have a mass with the initial velocity. This is initial speed, initial velocity of 2. Then here we have mass M2. And this time, after the collision, it will now be V1, and this is for the mass 1. And then this is V2 for the mass M2. So remember, if we say this one is moving, is now approaching this one so that they collide, it means that this will hit another, and then after the collision, maybe one will move like that, another will be moving by this velocity. I think that you are following this. Then the conservation law of this linear momentum is telling us that after this collision, what we have is the mass, there is a conservation of this linear momentum. Here we have mu1 plus m2u2. This is the linear momentum before. In another way, you can now say this is linear momentum before, and it is going now to be equal to linear momentum after. So this is going now to be after, here it is before, right? And as what you see, before it is the sum of the two linear momentum of each individual mass. I hope you are getting this. And then here we have equals to mass M1, V1 plus M2, then V2. It is like a reminder that you are now giving you. Because you've studied these things into senior 3. Do you remember this? So then students, we have, of course, as what we are saying there, sum of momentum before reaction equals to the sum of momentum after reaction. This is what we have there. So then this is what I've told you. Here it is the initial velocity of the first object, initial velocity of the second object, and this is the final velocity of the first object and the final velocity of the second object. And then this is the mass of the first object and the mass of the second object. So you can understand this from, of course, from the activity that we have, the very simple example. So I have an example here. And I want you to read this example and then try to understand. And then we move to the correction of this activity. A car of mass 600 kilogram. Let's start that. I think that I can remove this one so that now you observe this correction that we have, a correction so of this example. So here we have the mass M1. We identify like this. So given mass 1 equals to 6. Yes, you can now tell me. So, and then we have, you have U1 equals to, yes, that is 40 meter per second. And then afterward, we have a collide with that B. So this is for A, and then there is B here. B, we have a mass of, this is a mass of what? This is M2 equals to 8 kilogram. And then we have a V2. No, this is U2 because it is initial. That is at 30 meter per second. And then we have to explain what will happen after. So after the collision, what is going out to be that one? It moves by the impact. What is the velocity V of the car A immediately after the crash, after this one? If the car B moves forward at this one by the impact, what is the velocity V of the car A immediately after the crash? Now look what we have here. So as what we have defined it, the conservation say that we have M2U2 equals to M1 V1 plus this is the M2 V2. Okay, students, now let's use the conservation law of linear momentum to substitute the data. So here we have the 6 times 40 plus what we have there is 8 times 20. Then this has to be equal to 6 times the speed that it has moved with, plus that is 8. Then you have V, the speed that you are going to find. If we add these ones, and here we are going to find, we have 2400 plus 1600, then equals to 118. This plus 800 V. So this time now we have 40,000, which is subtracting by 118 equals to 8 V. So this can give us V equals to what? Then we can find that is, did you find the answer? 27.5 meter per second. This is what we find as the speed. Then students, let's have this is the application. You know, before the explosion, both objects stick together at rest. So after collision, both objects move at opposite direction. So the total momentum before collision is 0 before. So, okay, because they are all stick together. So then after the collision, the total momentum after collision is this one. So here we have the total momentum after. So from the law for conservation of linear momentum, what we have is this expression. So what we have by this side is 0 because nothing that is moving, right? And then we can have this M1 equal times V1 equals to minus M2 V2. Then students, before I leave you, I want to give you a homework. So the homework that you have here, it is now composed by 3 questions. They are all related to what we have discussed here. And I wish you to meet again when you have done all of these questions, okay? Be good. Bye-bye.